Okay, welcome. My name is Joris van den Bossen, and I'm going to introduce you to the GeoPandas library. Maybe just because I'm also curious, who has already heard of GeoPandas before? And who has already used it? Few people, cool. So very short about myself. I'm a PhD, bioscience engineer studying in Ghent, but I'm currently working in Paris for the Paris-Saclay Center for Data Science, and I'm also a core developer of Pandas. So for this audience, I don't have to explain the difference between raster and vector data, but showing this to say that in this talk I will focus on vector data. So if I'm talking about geospatial data analysis, in this talk is about vector data. It's about the typical simple features with attributes. Again, for this audience, I also don't have to explain that there is a lot of open source geospatial software where full stacks of tools are built upon. You have GDAL, you have Geos. But again, that's to say that in Python it's no different. There are a lot of Python packages, which already have been mentioned in previous talks as well, that build upon those base libraries. So you have, for example, PyPro for Py4, and Raster.io and Fiona and Shapely have already been mentioned. Fiona for the vector features of GDAL, Shapely wrapping the Geos library. So I'm going to shortly look a bit more in detail in Shapely. So its interface, it's using Geos under the hood and provides you all the capabilities, the geometry objects, and all the spatial operations predicates that you would like to do on them. Very short code snippet to show you a bit how it looks like. So you can create a point, create a line string, can do an operationally, for example, buffer, which creates polygon. And then I can check with a special predicate whether the polygon contains the point. So a very nice API to Geos. But the limitation of Shapely is it's based around those single objects, while in practice you often, of course, have many of those points or lines. And there's also no easy way to work with attributes. So not with the typical data that is attached to your geometrical data, your geometrical data. On the other hand, in Python there is a very strong ecosystem of tools to work with data. So Pandas is one of those packages that is with the reasons for the increasing use of Python in data science, machine learning, and academic research in general for data analysis. It provides data structures typically specifically to work with tabular data. So spreadsheet-like data, like R data frame. You also have a Pandas data frame, and very similar things that maybe you could do with SQL database tables. You can also do with Pandas. Again, a very small snippet. So you have a lot of input-output functionality, and you can do, there are two operations. The first one is a Boolean filtering, which would be in SQL a where operation, and a group by operation. So many of those typical data manipulation things are available in Pandas. So now, what is GeoPandas? GeoPandas tries to combine Pandas with the abilities of Shapely to work with geometry objects. And in that way, it tries to make it easier to work with a bunch of geometry objects and its data attributes. It was started by Kelsey Yordal already a few years ago. And it's not only Pandas and Shapely that it will build upon, it also builds upon many of the other libraries, for example, Fiona and GDAL for the input-output, PyPro for reprojections, R3, spatial index, etc. But to give you really a bit an idea of what is it? What it is? How it does it work? Let's try some live demo, and I will increase this in size. This is fine size. So importing a few things. So the first thing that GeoPandas can do, of course, you want to get data from somewhere. There is a lot of input-output functionality, mainly based on Fiona and thus on GDAL. As an example, data throughout this notebook, I downloaded some data about the bicycle sharing system in Paris, different stations and how many bikes there are in the stations. And I also, as a GeoJSON file, it's not fully visible, but you see it's a GeoJSON file. And also, so can read in that. You see here how it looks like. I show the first couple of rows. So you have your attributes and then a column, in this case called geometry, which are your geometrical objects. And for this data, it are points. But I also downloaded the different districts of Paris. And if I read in that one, you will see here, if I scroll a bit inside, here my geometries are polygons. So what are those things that I showed? If you look at it, it's a geodata frame. So it's just a data frame, like Pandas does. So with all the ability to handle, to manipulate this data frame, but with a special column, your geometry column, which will enable all the geospatial operations you want. So this column can always be accessed at .geometry. So here there are my points, which is called a geoseries in this case. And if you access a single element of that series, you will get back those shapely objects. So you still have the interface of shapely available on the single objects. As I said, it's still a data frame, so all the typical operations you can still do. For example, here, what I do here, just one example, I do some Boolean filtering by saying I only want those rows where the station is actually open, it's actually a working station. Or that's one of the other abilities of Pandas to quickly visualize some of the other some of their attributes. For example, here is the number of bike stands in all the stations, so you see a distribution of them. But since it's now a geodata frame, you also have access to all the typical operations and predicates that are available in geos. For example, I want to, for each district, the area. In this case, yeah, it's in latitude, longitude, so the area is not saying that much. Or I could calculate for each station the distance to a single point. So I took, I searched for using GeoPy the coordinates of the Notre Dame in Paris. So this is this point. So now I want to know what is the distance from all my stations to that point. And then again, you can very easily calculate those. And you get vectorized element-wise operations for all geometries in the object. Another one is, for example, contains. So which district contains the Notre Dame? Gives you true and false values. So I can do a filtering operation. And you can indeed see that this is the quartier, which is called Notre Dame. So it's logical that the Notre Dame is there. So all the other typical covers, crosses, intersects, all those operations are available as methods on a geodata frame and a geoseries. Another thing that GeoPandas provides is using Matplotlib under the hood to very quickly visualize some basic visualizations of the data that you have. For example, I can plot all the different districts, or I can give them some coloring, or some other column. Yeah, you have All the styling options of Matplotlib are available. Just to show you a few of them. The stations are a bunch of points. So because it would be easier to see where is something located, if I put some streets behind it, I downloaded using another library, OSMNX. I saved the streets of Paris as a shapefile, which I read in here. So this is my data, and you will see now I have line strings in my geometry column. So now I can quickly plot some streets on it. And I can also give coloring based off one of my attributes, which is also something you might want to do. So here the coloring means the number of available bikes. Yeah, over here something else, the bigger district. So some basic operations, some visualization, and of course GeoPandas also has the ability to do some more advanced operations like spatial joins, overlays, and things like that. So here a small example of a join, where I want to join for each station in which district it lies in, it's located in. So I can join them, and now you will see that here at the end there is a new column added to my stations, so the name of the districts. And then, for example, I can, for example, group by based on this name and count the number of stations in each district. Yeah, I'm not going to go into too much detail here, but then I can, for example, plot the number of stations of each district. Okay, so that was a very short demo of what GeoPandas looks like. So it gives you a lot of read-write ability, general manipulation of your data, all the geospatial predicates. What I didn't show that you can also easily reproject from your data, and then visualization and charts. Yeah, so I hope that, and for me at least, one of the strengths of using Python with GeoPandas, that you can very interactively explore and analyze your data. There are also a lot of other libraries that I didn't mention here that work or can work with GeoPandas data frames, but yeah, I don't have time to go much deeper here. So I hope that I've shown a bit that it can be rather, it gives a nice interface, an easy interface to work with your geospatial data, but it is also fast. It's also a bit somewhat performant to do that in Python. So at the moment, GeoPandas can be rather slow if you have a lot of data. In the demo that I showed, it was no problem at all, but of course it was a very small data set. So it's always a bit difficult to say what is slow, what is fast. You see for 100,000 points, within a simple distance operations, each take more or less a second. And once you do, if you do that many times, which is typical in some analysis, it can be quickly add up. But you have some more an idea. I did a comparison with PostGIS. You don't have to go into the detail of the spatial join. So it's an example from the boundless tutorial. I have to say I'm not a PostGIS expert, so I don't know if it's an optimized query or if my system was optimized. But anyhow, it gives some interesting things, because you can see that PostGIS is a lot faster than GeoPandas, while it's actually based on the same library under the hood. It's both using geos for the same things. So why is GeoPandas slower? It's because there's a lot of overhead in the way that we use. So if you use call a distance operation in GeoPandas, we will loop over our objects, call Shapely, and Shapely then calls geos. So that creates some overhead. So luckily, there is a new version of GeoPandas in development, which tries to reduce this overhead by only storing the pointers to the actual geometry objects and calling geos directly. But still, if you access a single point, you still get a nice shapely geometry object. So the same API, it will have exactly the same API, but much better performance and also memory use. Result, well, it was before, and now the green with the new version. So on very simple things, you get 10 to 100 times speed up. But you also see that for a bit more the advanced ones, that we're now much more or less similar as PostGIS, which is actually also somehow to be expected since we're using the same library under the hood. So you can read a lot more about those developments on those two blog posts. You can also very easily install it with Conda. There are libraries, binaries available for the development version as well. So you can, if you want to try it out, certainly welcome. So it's, yeah, still new. So some real world usage is certainly welcome to test it out. So you see that the next version will also be fast, but is it also scalable? Because the Python ecosystem based on NumPy, Pandas, so it's a very strong ecosystem, also optimized, fast. As long as you're working in memory, single core, then it's very optimized. It's a typical limitation of the ecosystem in Python. But there have been some, over the last years, developments, and one of the more popular ones is Dask, which is a library that provides parallelism and distributed computing. It's written in pure Python, but lets you work on larger than memory datasets from just your laptop to use all the cores to big machines with many cores, or distributed system with thousands of cores. How does it do that? By just using the existing ecosystem. It just uses Pandas or NumPy, but it will use blocked algorithms and create task graphs, and it has a scheduler to then execute those task graphs. So we can use Dask as well to parallelize our GeoPandas. And there has been an experiment. So there was a blog post last summer of Ravi Shekhar, who did on the taxi data of New York. It had 120 million rows of records of a person who somewhere took a taxi to another place. And what he wanted to do was, for each of those rows, do a spatial join with the districts or the taxi zones to know for each point in which taxi zone did it start and end. So on his laptop, it took more than 3 hours with the version then. Matthew Rocklin, the person who collaborated with me on the new developments, tried it out on his laptop, and he was able, with a new version and with parallelizing it, to be able to do it in 8 minutes. And this is based on Dask GeoPandas, which is a very experimental library to also parallelize the computations of geos. So I will almost stop, so there's still some time for questions. But what I would like to show you, just to also get an idea. So this is the final plot for each taxi zone that they made. For each taxi zone, the color gives the amount of trips that were started in that zone. They did that on 100 for the full all data of 2015, which are 120 million records. I did a small replication of it, but with only 10 million records for 1 month. So with the current version of GeoPandas, it took me about 20 minutes. With the new version, it decreased to 2 minutes. And I'm now going to run it in parallel on the 4 cores of my. So it created a kind of cluster. Of course, on my machine it's not a real cluster because I only have one worker with 4 cores. But I want to show you, so these are the different zones. There are 263 zones. So it's a data set of 1.6 gigabytes, around 10 million rows. And what I will do is I will read in the data set to CSV file. I will do a spatial join with the zones, and then do some calculations on that. Just to give you an idea, Dask will then create a task graph. It does it all in chunks, and this task graph will then be executed. It can be executed on a local laptop, but also on a distributed cluster. First, going to open here the dashboard that Dask provides. So we can see what is going on. So now I will execute this, and hopefully, if I go to the status, yeah. So you can see a bit the progress of the calculations of the different tasks. You can see that it uses my 4 cores. And you can also see, so the blue blocks here are the spatial joins. And so you can see that it's actually doing spatial joins on parts, subsets of the data on all the 4 cores, so in parallel on my laptop. And this can very easily be scaled to a big machine with many cores or even a distributed cluster. And normally it should take around, in this case, around 1 minute. So on my laptop with my 4 cores, it went from 2 to only 1 minute, so it's not a huge speed up, but if you have many cores, it could be certainly more helpful. Well, it was the last demo, so thank you for your attention. A little bit time for questions, I think. Yeah.
Do you also support different ways of storing the data? Next to local bits, stuff like copy or both?
Yeah. So at the moment, the built-in .plot method is based on Matplotlib. But yeah, for example, the plot in the blog post that I quickly showed was actually a bokeh plot. So you can use or a leaflet or bokeh, but they are not built in GeoPandas itself. But it could be added, and it's also certainly possible to plot with them.
The last demo was really interesting, and I was just wondering, can we replicate the same thing but zonal statistics scheme, having a raster and boundaries and distribute everything through a combination of the pandas and Dask?
If it would be possible, or
Yeah, if it's possible, do we have the infrastructure? GeoPandas has already the infrastructure to do that.
to do that you do it in especially.
Yeah, zonal statistics through pandas and Dask.
Yeah, that should be possible. At the moment also, so one of the things what I didn't mention is now the data was just partitioned in chunks, and in principle they can also be partitioned in by zone. That you can even get a more efficient. Certain AI operations can be more efficient if they are partitioned by zones. But yeah, just in general, not.
That's GeoPandas already has the infrastructure to do zonal statistics with the rasters.
No. So with at the moment to combine it with raster data, there is nothing built into GeoPandas itself. Yeah. Sorry.
One more question. When handling like 100 million points, do you have any kind of indexing, like cost?
Yeah, so the question was, if you're handling 100 million of points, is there a spatial index? So in GeoPandas, in the current version, we use R3 Python package, which is based on lib spatial index, which is used in the spatial join. In the new version, where the Cytonized version, we use the str3 of Geos to improve the spatial joins.